Hello tonight. Before you drift into sleep, try to imagine something very unusual. Not a disaster, not the end of the world, but the absence of them. Listen carefully to what surrounds you right now. If there is no wind howling outside your window, if the ground beneath you is not trembling, if the sky is not glowing red with ash or fire, then perhaps at this very moment you are standing inside something extremely rare in the history of Earth. Not human prosperity, not human peace, but the quiet of the planet itself. For more than 4 billion years of existence, Earth has rarely been quiet. Most of the time, it has been a place that could not be lived on for long. A world where rocks fell from the sky, where oceans evaporated, then returned as acidic rain, where volcanoes erupted for thousands of years at a time, and where the climate shifted so rapidly that life barely had time to exist, let alone stabilize. If there is one thing geological history teaches us, it is this: instability is not the exception. Instability is Earth's normal state. Periods when the planet does not shake violently, does not freeze over globally, does not suffer bombardment from space, are brief moments, fragile moments that often pass without leaving a clear mark. And then, only very recently by the standards of geological time, Earth slowed down. Not because it became safe, not because dangers disappeared, but because in a rare convergence of orbital paths, axial tilt oceans, atmosphere, and the absence of major impacts, the colossal forces that once shaped this planet's fate temporarily fell silent. There was no explosion, no first day of a peaceful age, no one standing there to record the moment it began. But within that silence, something that had never happened before was given enough time to form. Humans began to stay in one place, not to hide but to belong. They planted seeds and trusted that the next season would return. They built homes believing the ground beneath their foundations would not vanish. They watched the sky not to flee from catastrophe, but to learn the repeating rhythms of time. Civilization was not born from an explosion, it was born from stable repetition. And here lies the deepest paradox. Today, humans have never felt more anxious than they do now. We live surrounded by warnings, by forecasts, by a sense that everything is fragile and on the verge of breaking. And perhaps at the level of human society, that feeling is real. But if we step back far enough, far beyond human history, far beyond memory and fear, there is a possibility that makes us slow down, that when viewed across the full span of Earth's existence, we may be living in one of the quietest periods this planet has ever known. Not quiet because danger no longer exists, but quiet because the greatest dangers are temporarily dormant. No massive asteroid, no supervolcano darkening the sky, no ice age swallowing continents, no global oceanic die-off. Only regularity, a regularity so fragile that we rarely notice we are standing inside it. Tonight, in this story, we will not speak about the end of the world. We will speak about something far harder to see, a rare moment when Earth is calm enough to allow complex life to persist over time and to allow humans to tell their own story. Not to reassure, not to deny risk, but to understand this. Peace, when it appears, is usually quiet, and because of that, it is very easy to overlook. If there is one major mistake modern humans often make when thinking about Earth, it is the belief that stability is natural, that blue skies, solid ground, and familiar oceans beyond the horizon are the planet's default state. But for most of its history, Earth was not a place that could be described as stable. It was not a gentle home waiting for life to arrive and settle in. It was a process unfolding, a colossal energy machine. And for a very long time, that machine operated in ways that complex life could barely endure. Let us turn the clock back far beyond memory, far beyond any story humans have ever told one another, beyond history, beyond language itself, back to roughly 4.6 billion years ago, when Earth had just formed from a swirling cloud of dust and gas around a still young sun. At that moment, this planet was not yet a world, but a mass of material slowly cooling after countless violent collisions. During the Hadean eon spanning roughly 4.6 to 4.0 billion years ago, Earth's surface was never truly stable. The crust was thin and fragile, constantly melted from below. Residual heat from planetary formation, combined with radioactive decay of heavy elements, turned the surface into something closer to a global magma ocean than solid ground. There were no continents, no coastlines, only hot rock moving, reshaping itself, never holding one form for long. The sky did not carry the familiar blue we know today. It was thick, dark, and opaque, a heavy mixture with no free oxygen, carbon dioxide, methane, ammonia, water vapor, and sulfur-rich compounds with a metallic stench. Sunlight from the young sun did not illuminate the sky. It diffused through the haze, creating a dim glow like a fog that never lifted. Day and night existed, but without the rhythm we recognize. Earth rotated faster. Time itself moved differently. If anything at that stage could be called an ocean, it bore little resemblance to what we know today. Around 4.4 billion years ago, as the planet cooled enough for water vapor to condense, rains fell for millions of years. But this water was not gentle. It was hot. It was acidic. It evaporated constantly, only to return again in a violent cycle. These bodies of water did not nurture life. They eroded rock, reacted with metals, and participated in reshaping the planet's entire surface. And throughout this time, Earth was anything but calm from the outside. Between roughly 4.1 and 3.8 billion years ago, the planet entered what scientists call the Late Heavy Bombardment. Asteroids ranging from small fragments to massive bodies, tens of kilometers wide, slammed into the surface again and again. There was no thick atmosphere to burn them away, no stable oceans to absorb the impact. Each collision released energy comparable to millions of modern nuclear bombs. Every impact tore the ground open. Mountains, if they had time to form, were flattened instantly. Oceans vaporized only to return later when the sky cooled and rain fell once more. The planet's surface was erased and rewritten repeatedly, like a manuscript never allowed to be finished. There was no geographical memory. No place endured long enough to become a homeland. Even as the bombardment gradually waned, entering the Archean eon around 4.0 to 2.5 billion years ago, Earth remained far from gentle. Volcanism dominated the surface. Basaltic lava flows stretched for hundreds of kilometers cooled, then were shattered by the next eruption. Proto-continents, small, fragile, and temporary, appeared and disappeared. Climate swung violently without any stable cycles recognizable to modern humans. For hundreds of millions of years, there was no concept of normal. No long-term average temperature to rely on, no fixed sea level, no seasons in the familiar sense. Earth was not waiting for life to develop. It was a system constantly adjusting itself, colliding, reorganizing, reshaping, and anything existing upon it had to accept continuous change. The mere fact that the planet was not completely destroyed is remarkable in itself. And if anything survived this era, it was not because of stability, but because it could endure a world that never stood still. This was not a brief phase. It lasted hundreds of millions of years, and during that time, quiet was almost non-existent. Earth shook constantly, without predictable cycles, without regular rhythms. The forces driving the planet were indifferent to life. They followed only physics, thermodynamics, and energy. Even as the heaviest impacts diminished, Earth did not become gentle. Energy from its formation continued to escape from within. The fragile crust stretched, compressed, and tore. Volcanoes were not isolated events, they were the norm. Lava flowed for hundreds of kilometers, covered everything, cooled, and was broken apart again by the next eruption. Climate, if the term even applies, shifted without recognizable patterns. Global temperatures could rise or fall by tens of degrees over intervals we now consider short. Oceans did not merely rise or fall, they could nearly vanish from the surface, then return as rainfall lasting thousands of years. In such a world, life could not rely on stability. It could only cling, adapt, and hope. And when life finally did appear, simple, fragile, almost invisible, Earth continued to test it. There was no moment when the planet made room for new organisms. Every form of life had to survive in a constantly changing environment where what worked today could become fatal tomorrow. Billions of years passed this way, not as a straight line of progress, but as oscillations. Warm, then cold. Wet, then dry. Brief stability, then collapse. Organisms emerged, flourished, and vanished, not because they were weak, but because Earth kept changing the rules. Whenever the planet allowed life to expand, it soon withdrew those conditions. Ice sheets covered continents. Oceans lost oxygen. Volcanoes darkened skies for years. These were not rare exceptions. They happened again and again. Each time, life had to restart from what remained. In this context, the concept of stability barely has meaning. There was no long-term average temperature, no fixed sea level to plan around, no gentle climate cycles for planting or accumulation. Earth was not a stage built for life. It was a process in motion, and life was a small part trying to persist within it. What matters most to remember is this: for most of its existence, Earth has never truly stood still. There was no moment when everything paused long enough to stabilize permanently. Even in periods without obvious catastrophes, no massive impacts, no global ice ages, no mass extinctions, the planet's foundational forces continued operating quietly, constantly, without ever stopping. Continents are not fixed. They drift. So slowly that humans cannot feel it in a lifetime, yet so persistently that over tens of millions of years the entire world map is redrawn. Regions once near the equator drift toward the poles. Oceans open and close. Mountain ranges are not built in a single event, but pushed upward millimeter by millimeter each year until they grow tall enough to alter climate wind patterns and rainfall across entire continents. Beneath the seemingly solid surface mantle, convection continues to move. Heat from Earth's core does not vanish, it finds new pathways to escape. Volcanoes may sleep for hundreds of thousands of years, then awaken. Fault lines may remain silent for generations, then slip in seconds, reshaping entire regions. Earth does not need constant disasters to change, it only needs time. Even the oceans, which we often imagine as stable and eternal, never stand still. Cold, deep currents flow slowly along the ocean floor, carrying heat salt and dissolved gases, linking all oceans into a single system. They shift direction, change strength, sometimes subtly, yet enough to warm or cool entire hemispheres over thousands of years. The atmosphere, too, has never been constant. Its composition changes over time with volcanism biology and geochemical cycles. Some changes occur so slowly that only millions of years later, through sedimentary rock and fossils, do we understand what happened. These shifts are not sudden disasters, yet they can push global climate into entirely new states. In this context, stability, when it exists, is always temporary. It is a fragile balance between powerful forces where none dominates for a time. But that balance is not guaranteed. It is the exception, and it can break without warning. Against this long-term backdrop, what we call bad weather, today is little more than surface ripples on an ocean that was once far more violent. Storms, harsh winters, prolonged droughts, while devastating to human societies, still occur within a relatively stable framework. Global temperatures do not swing by tens of degrees in a few decades. Sea levels do not rise or fall by tens of meters within a single lifetime. Ecosystems, though stressed, still have time to respond. This does not diminish the seriousness of the challenges humans face, but it places them within a broader context, one that shows Earth has endured eras where even fragile stability was a luxury. Compared to those times, the present world resembles a rare pause, a moment when the great forces still exist, still move, but are not colliding violently. That quiet difference is what makes the present moment special in a very subtle way. Not because it is perfect, not because it is absolutely safe, but because it allows fragile structures, complex ecosystems, civilization itself, to persist long enough to accumulate, to remember to grow. Seen across the full span of geological history, the sense of normality we experience today is profoundly unusual. It is not Earth's natural state, but the result of a temporary balance among forces that constantly seek to disrupt balance. This truth often unsettles us because it undermines a familiar feeling that Earth is a solid foundation. For most of its history, the planet has resembled a raging river more than a flat, stable ground. And if that river ever slows, it is not because it has changed its nature, but because certain conditions have momentarily balanced. Looking back at this deep past, we begin to understand something essential. Quiet is not Earth's natural condition. It is rare, a brief exception in a long history of turbulence. For billions of years, life has survived not by trusting stability, but by enduring change. This makes the present moment special in a very different way, because if Earth was once a place of constant upheaval, then any period in which major forces temporarily subside carries far more significance than it appears on the surface, not because it is perfectly safe, but because it allows fragile structures, complex ecosystems, civilization time to form. But to recognize how special this is, we must first accept a simple truth. Earth was never designed to be gentle. Any sense of calm we experience today does not come from the planet's inherent nature, but from a rare convergence of physical conditions, a convergence that did not exist for most of Earth's history. And from that violent foundation, the central question of this story becomes clearer. If Earth was once a place of constant change, constant harshness, always ready to erase what could not adapt, then what has allowed it, at least for a brief recent period, to become so quiet? To answer that, we must continue forward, leaving behind the chaos of the early planet and entering moments when Earth did not merely change, but nearly wiped life away entirely. That is the story of the mass extinctions. Sometimes this planet doesn't merely change, it clears the board, not in a single explosive instant that ends everything at once, not with one lone blast so loud that history has to stop, but through sequences of events that unfold over time, slowly, almost indifferently, yet utterly without mercy. Small changes stack on top of one another. Familiar conditions begin to fade. The boundaries of survivability are pushed back step by step until life realizes there is nowhere left to retreat. In moments like these, Earth does not act like an angry destroyer. It behaves more like a self-regulating system, cold, precise, and exact. When fundamental balances are pushed too far out of range, the planet does not try to preserve the biological structures that exist. It rebuilds the environment itself, and life, if it cannot adapt in time, is simply left behind. Over its immense history, Earth has done this not just once. Scientists call these moments mass extinctions, periods, when a very large portion of biodiversity disappears within a relatively short span, measured against the slow flow of geological time. Short here does not mean a day or a year. It may last tens of thousands, sometimes even hundreds of thousands of years. But compared to the millions and billions of years in Earth's history, these are still compressed, urgent moments when life does not have time to turn itself around. There have been 5 such events identified clearly. 5 moments when global ecosystems collapsed on a vast scale. But what matters most is these events are not copies of one another. They do not follow the same script. There is no single cause, no fixed extinction formula. Sometimes it begins with cold. Sometimes it starts when the ocean runs out of oxygen. Sometimes it arrives through prolonged volcanic eruptions. And sometimes it comes from a small object in space slamming into Earth at unimaginable speed. On the surface, they look very different. But beneath all those differences, one quiet thread connects them: the destabilization of Earth's foundational systems. When climate leaves its familiar range. When the oceans stop working the way they used to. When the atmosphere shifts faster than organisms can adapt. When cycles that once fed life begin to betray it. In those moments, complex life has nowhere to hide. There is no safe corner, no lasting refuge. Species that dominated the seas or the land for millions of years suddenly become fragile, not because they are weak, but because the world around them has changed the rules. Mass extinction is not punishment. It is not moral. Earth does not choose which species to keep or discard. It simply responds to physical and chemical forces that have crossed a threshold of balance. And in that response, many forms of life, no matter how successful they once were, simply stop fitting. What makes these events so haunting is not only the scale of destruction, but the calmness of the process. There is no climax, no heroic moment, only a prolonged reality. The world slowly becomes unlivable in the old way, and species ecosystems, one by one, quietly vanish. When we look back at those 5 extinctions, we begin to understand that the continuous existence of complex life has never been guaranteed. It has always depended on a fragile chain of balances. And whenever that chain breaks, Earth does not hesitate to rewrite the entire story. The first occurred around 444 million years ago, at the boundary between the Ordovician and Silurian periods. At that time, life existed mainly in the oceans. Marine organisms flourished in a warm world with high sea levels and relatively stable ecosystems. Then a sequence of climatic changes began. Earth cooled. Ice caps formed rapidly at the South Pole. Sea levels dropped by tens of meters. Shallow seas where most life was concentrated disappeared. There was no explosion, no asteroid, only prolonged cold and the retreat of water. Around 85% of species vanished. Life did not die from violence, but because the environment it depended on ceased to exist. The second extinction at the end of the Devonian did not arrive like a storm that sweeps through and then is gone. It came slowly. So slowly that if you were living in that era, you might not realize you were entering one of the greatest collapses life has ever faced. There was no single moment to mark the beginning, no clear line between before and after, only a lingering sense the world was becoming less and less livable. Between roughly 372 and 359 million years ago, the oceans home to most complex life began to change in quiet but profound ways. Oxygen in the water did not disappear all at once. It withdrew little by little. Deep waters, once stable refuges for countless organisms, slowly became suffocating. Water layers stopped mixing the way they used to. Oxygen from the surface could no longer reach the depths. And when that cycle broke, the very foundation of marine ecosystems began to wobble. Not every creature died at the same time. First came those that needed the most oxygen, then those that depended on them. Food chains did not collapse in a day. They snapped link by link, slowly, almost soundlessly. Ancient coral reef systems that had existed and thrived for tens of millions of years began to decline. They were not destroyed by a single catastrophe. They simply no longer had the conditions required to continue. The cause of this decline was not one factor alone, and that is what makes the Devonian extinction different. It may have involved shifts in nutrient cycles as more nutrients washed from land into the sea. It may have involved volcanic activity altering ocean and atmosphere chemistry, or it may have involved something less dramatic yet far more transformative: the explosion of plant life on land. In the Devonian, for the first time in Earth's history, vascular plants expanded strongly across continents. They grew deep roots, broke down rock-released minerals, and completely changed how nutrients entered the oceans. Those early forests did not merely green the land. They inadvertently reshaped the chemistry of the sea. When nutrients rose too high, algae and microbes bloomed. When they died, decomposition consumed oxygen, leaving dead zones, waters where complex life could not survive. But there was no day when the ocean died. Only zones that expanded as life gradually retreated. Species that once dominated the seas did not vanish in a single generation. They weakened over many generations, each born into lower oxygen waters than the one before. Reproductive success fell. Body sizes shrank. Ranges narrowed. Until a species disappeared, not because it was destroyed, but because the conditions required for its existence were no longer present. Around 75% of species vanished during this period. That number did not come from one moment, but from the accumulation of countless local declines. A world that did not collapse suddenly, but faded slowly, like an oil lamp that burns steadily, then grows weaker until the light is no longer strong enough to reveal the shape of what once existed. What makes the Devonian extinction so haunting is the absence of a climax. No single event to retell. No clear villain that caused the disaster. Only a chain of changes so slow they became background, while life was forced to adapt as that background quietly pulled away beneath its feet. In such a world, the survivors were not the strongest, but those who could endure scarcity, those who needed less oxygen, those who could tolerate instability. And when the long decline finally ended, those survivors became the foundation for the next phase of life, in a world completely unlike the one before. The late Devonian extinction leaves no dramatic images behind, but it leaves a quiet lesson. Life can disappear without loud catastrophe. Sometimes, if familiar environments become just slightly less suitable with each generation, an entire world can slide into oblivion. But no event prepared life for what came around 252 million years ago. At the end of the Permian, Earth experienced the largest mass extinction ever known. More than 90% of marine life and 70% of land life disappeared. Coral reef systems that had existed for hundreds of millions of years were nearly erased. The cause was not a single factor, but a deadly combination. Massive volcanic activity in Siberia released enormous amounts of greenhouse gases, driving rapid warming. Oceans warmed and lost oxygen. Toxic gases spread. Biological cycles collapsed. In such a world, life had no chance to adapt in time. This was not an instant catastrophe. It unfolded over tens of thousands of years, where each generation faced worse conditions than the one before. In the end, nearly all of life's diversity was swept away. Afterward, Earth did not recover quickly. It took millions of years for complex ecosystems to return, and when they did, the world was different. The dominant species were gone. Familiar ecological structures vanished. Life began again, not from zero, but from a far poorer foundation. The fourth mass extinction, around 201 million years ago, did not begin with a single shock. It marked the boundary between the Triassic and the Jurassic, a boundary not drawn by a clean line, but by a long period of upheaval. Earth did not collapse in an instant. It opened, and that opening slow as it was changed the entire structure of life on the planet. During this time, the supercontinent Pangaea, the enormous landmass that once joined most of today's continents, began to break apart. The separation was not gentle. As tectonic plates pulled away, Earth's crust cracked open, allowing continent-scale volcanism to continue for long spans of time. Lava did not pour from one isolated volcano. It erupted along fissures stretching thousands of kilometers. For hundreds of thousands of years, the surface was repeatedly covered by fresh layers of basalt. These eruptions released vast quantities of greenhouse gases into the atmosphere. Climate began to swing hard. Temperatures rose. Rainfall cycles changed. Oceans absorbed heat and carbon dioxide, becoming warmer and more acidic. Ecosystems that had relied on Triassic stability began to lose the ground beneath them. There was no apocalypse day, only a spreading sense the world was changing faster than most organisms could adapt. Species that depended on stability weakened first. Complex food webs began to crack. Populations shrank, fragmented, and vanished. About 80% of species did not survive this transition. What matters is that the collapse did not leave a world entirely empty. It left ecological vacancy roles in ecosystems with no one to fill them. Places once held by Triassic dominance were suddenly open, and inside that vacancy, evolutionary history turned in a new direction. The creatures that rose afterward were not winners of some fierce contest. They did not defeat anyone. They arrived at the right time. They carried traits that fit the new world: better tolerance for temperature fluctuation, an upright stance that made movement more efficient across wide landscapes, and reproductive strategies flexible enough for unstable conditions. These were the animals we would later call dinosaurs. In the early Jurassic, dinosaurs were not yet the giant rulers of the planet. They were one group among many testing new evolutionary paths. But the world they entered was different. Climate was warmer. Continents were splitting, creating more varied habitats. Competitors that had held major ecological roles were gone or weakened. And in that context, dinosaurs did not need to be superior. They only needed to fit. Their rise was not a guaranteed victory. It was the result of an entire system being rearranged after a period of upheaval. When Earth rewrote its operating rules, the creatures able to live under those new rules became the leading characters of the next age. The Triassic to Jurassic extinction therefore carries a special tone. It is not only a story of loss, it is a story of a quiet smena, a world ending not with a blast, but with the slow movement of continents, the gradual accumulation of gases in the sky, and the silent transformation of climate. And within that silence, a new chapter of life began. Looking back, we see Earth does not only erase, it also clears space. But that space is never opened to serve one specific species. It simply reflects new physical conditions. And any organism that happens to fit those conditions, no matter how modest it seems at first, can become the center of an era. The fifth mass extinction, and the one most familiar to modern humans, occurred about 66 million years ago at the boundary between the Cretaceous and the Paleogene. A massive asteroid struck what is now the Yucatan Peninsula. The sky darkened, global temperatures dropped sharply, food chains collapsed. Around 75% of species disappeared, including all non-avian dinosaurs. This is the rare event that carries the shape of a sudden blow. And yet even here, its consequences unfolded for thousands of years afterward. What stands out is not only destruction, but repetition, 5 times in different contexts with different causes and the same outcome. When Earth's foundational systems, climate, oceans, atmosphere, are pushed beyond the stable range complex, life collapses quickly. There is no special protection, no guaranteed safe zone for biodiversity. Life exists as long as conditions allow and vanishes when conditions shift too quickly or too deeply. This leads to a crucial realization. Periods stable enough for complex life to develop over long spans are not guaranteed. They are exceptions. And whenever that exception ends, Earth does not hesitate to rebuild its entire biological system. After each mass extinction, life always returns, but it never returns the same. Survivors are not the best, but those that fit the new conditions. Each time evolutionary history takes a different turn. Paths once possible vanish forever. New possibilities open, but only because the old world has been erased. Looking back across this chain of events, we begin to see that the continuous presence of complex life is not something to take for granted. It depends on a fragile balance among multiple vast systems. And whenever that balance breaks, Earth does not repair gently. It resets the board. Compared to those times, the present stands out, not because danger is absent, but because the great global foundational shocks are absent. No sign of an abrupt ice age swallowing continents. No chain of eruptions large enough to collapse climate over a few thousand years. No evidence of an imminent asteroid impact capable of instant devastation. The great systems are still operating, still changing, but they have not been shoved suddenly out of balance as they were in those 5 moments. That is what makes the present moment distinctive, not because it is permanent, but because it is rare. History suggests that periods when life can continue developing for tens of thousands of years without being interrupted by mass extinction are not many. And as we step out of this chapter, leaving behind the moments when life was nearly erased, a question begins to form. What has allowed the present period to last longer? What has kept Earth's systems within a narrow enough range to avoid triggering a new extinction? To answer that, we need to look deeper into one factor that has repeatedly reshaped this planet's fate: climate, and more specifically, the ice age cycles that would go on to shape the world across the next millions of years. If mass extinctions are the moments when Earth restructures life through deep and rapid shifts, then ice ages are the planet's way of testing endurance through time. Not through instant destruction, but through repetition. Cooling, warming, retreating, returning. Like a long breath stretched across millions of years where no state is allowed to last forever. When modern humans think of an ice age, they often picture a world completely covered in ice and snow. A blank white landscape, silent and still, as if Earth froze in a single moment and then held that condition unchanged. But that image, however powerful, hides the true nature of ice ages in Earth's history. For most of the time, an ice age is not a single continuous era that simply lasts and then ends. It is a repeating motion, a series of oscillations between cold and warmth, between ice advancing and ice withdrawing. There is no final state, no stopping point, only steady rhythms of change so slow that life is forced to redesign its entire strategy of survival. Cold phases do not appear and vanish within a few generations. They arrive gradually. Ice accumulates layer by layer, year after year, until immense ice sheets form kilometers thick, spreading outward from the poles. And in the same way, warmer phases do not erupt in an instant. They open through slow melting. Sunlight strikes at a slightly more favorable angle. Temperatures rise bit by bit. Ice retreats, leaving behind a new world, wetter, greener, but never exactly the same as the world that came before. These oscillations do not happen by the will of life. No organism triggers or prevents an ice age. They follow the cold physical laws of the cosmos, the way Earth moves around the sun, the tilt of its axis, and the shape of its orbit, all changing extremely slowly over time. These changes are so small, they are almost impossible to notice within a human lifetime, yet large enough to determine whether ice will accumulate or melt over the next tens of thousands of years. Over the last 2.6 million years, Earth entered what scientists call the Quaternary Ice Age. This was not the moment ice suddenly appeared everywhere. It was the moment Earth's climate began to lose its ability to maintain long-lasting stability. Since then, the planet has not remained in any single climate state long enough to be considered durable by geological standards. Instead, Earth oscillates. Between glacial phases, when ice expands, sea levels fall and new lands emerge. And interglacial phases, when ice retreats, oceans rise, and climate becomes milder. These cycles do not happen once and end. They repeat dozens of times, each lasting tens of thousands of years, long enough to transform the planet's entire biological landscape. During a glacial phase, the world is not only colder, it is drier. Winds are stronger. Ecosystems are squeezed into narrower refuges, places where enough water and warmth remain to sustain life. Species that cannot move or cannot endure harshness gradually disappear. But the moment ice retreats, the world opens again. Migration corridors appear, grasslands spread, forests return but never in exactly the same places as before. And what is striking is this: no cycle is identical to another. Each oscillation carries a slightly different set of conditions: the speed of melting, the degree of sea level, rise, the distribution of rain and wind. And those small differences are enough to split the history of life into branching paths. Evolutionary routes that are possible in one cycle may close in the next. In such a world, stability becomes a relative concept, not a fixed state, but a temporary window long enough for life to adapt before conditions shift again. And in the Quaternary, those long enough windows become increasingly rare. So ice ages should not be understood as a single disaster of the distant past. They are the background rhythm of Earth through the last few million years, a rhythm that forces every form of life, from microbes to large animals, to live in readiness for change. Nothing is permanent. No climate is guaranteed to last. And from that oscillating rhythm, we can understand why truly prolonged climatic stability, a time when ice neither surges forward nor retreats too quickly, becomes so valuable. And it is from that long instability that the central question of this story grows sharper. What made the present period different? A question that can only be answered when we step into the next chapter, where Earth, on a rare occasion, stops oscillating so violently and becomes still. These cycles are not random. They are guided by very small changes in Earth's orbit around the Sun, the tilt of the axis, the shape of the orbit, and the orientation of that orbit over time. These changes, known collectively as the Milankovitch cycles, unfold slowly across tens of thousands to hundreds of thousands of years. But their consequences are anything but small. A slight change in the amount of sunlight reaching high latitudes is enough to decide whether ice begins to accumulate or begins to melt. When glaciation advances, it does not surge downward like a violent wave. It creeps very slowly. But it does not stop. Ice sheets, kilometers thick, form at the poles, then gradually spread southward. They crush everything beneath them: soil, forests, rivers. Sea levels fall by tens of meters as vast amounts of water are locked into ice. Lands that were once seafloor emerge. Continents connect through temporary land bridges that exist only in the cold. And then, after tens of thousands of years, the ice begins to withdraw, not because of a catastrophe, but because sunlight returns at a slightly better angle. Temperatures rise bit by bit. Ice melts. Water pours back into the oceans. Sea levels climb again, drowning lands that had only recently appeared. Coastlines are redrawn. Rivers change course. Ecosystems must adapt again. There is no normal in a world like this. only continuous adaptation. For life, an ice age is not a killer that arrives and vanishes in an instant. It does not come as a single blow. It stays, like a weight placed upon the world day after day, generation after generation. A pressure so slow it does not cause panic, yet so persistent it forces every form of life to change or disappear. In a glacial period, life does not die en masse from one single cause. It is worn down, tested by the growing distances between places where survival is still possible, forced to move with the ice, then retreat when the ice comes too close. Species that cannot migrate fast enough, cannot cross cold and dry landscapes, or cannot endure prolonged shortages of food and water gradually vanish from the biological map, not because they are weak, but because the world becomes too wide to cross or too harsh to remain in. In that context, life learns to contract, ranges shrink, populations become smaller. Traits that were advantages in stable environments, large body size, high energy, need specialized diets, become burdens. Meanwhile, more flexible species endure better, smaller, faster breeding. Earlier able to eat many kinds of food, able to live with imperfect conditions. They do not rule the world, they wait. This is the quiet test of an ice age. It is not the strongest that survive, but the least dependent. Those who do not tie their existence to one single type of climate, one single food source, or one fixed landscape. In a world that constantly shifts, the ability to remain unchanged is not an advantage. The ability to change is what decides. But even when ice retreats and the world warms, relief does not last. Interglacials, when climate becomes gentler, rains return, forests expand, always carry a sense of fragility. They arrive like a breath, and like a breath, they do not stay long. These warm windows rarely last millions of years as they did in distant geological eras. Most exist only for a few thousand to a few tens of thousands of years. By Earth standards, that is a blink. By life standards, it is enough to recover, but never enough to forget that cold can return. And then without warning, the rhythm shifts again. Sunlight arrives at a slightly different angle. Summers at high latitudes grow shorter. Snow does not fully melt. Ice begins to build. Land that was green begins to dry. Migration paths close. Ice returns not as a new invader, but as a familiar reminder. The world has never chosen to stop in one single state. In that oscillation, life has no concept of normal. Only temporary favorable phases between long, harsh phases. And so every survival strategy becomes precautionary. No species is allowed to bet its entire future on a single climate. Ice ages, in that sense, are not one disaster, but a long training ground. A place where life learns to live with uncertainty, to move to contract, to wait, and then expand again when opportunity returns. And it is that rhythm of learning that shapes ecosystems deeply, more cautious, more flexible, always ready for a different world tomorrow. But precisely because of that uncertain rhythm, one crucial thing rarely happens across most ice age history: stability long enough for complex structures to take root. Life can return after each cold phase, but it returns already prepared to retreat again. And when we look at the present period, when ice is not advancing rapidly and not retreating abruptly, the difference becomes clearer. Because in a world that is used to never stopping, any pause that lasts longer than usual carries enormous meaning. In that context, life on land learned a lesson: nowhere is permanent. Forests expand, then shrink. Grasslands appear, then vanish. Species migrate with the ice, then withdraw with it. The planet's biological map is drawn and redrawn many times, not by the rhythm of civilization, but by the rhythm of ice and light. And through all those oscillations, one thing is notable: Earth does not collapse. Not every glacial cycle produces a mass extinction. Instead, life is ground down, tested, forced to change shape, range, and strategy. What does not fit disappears. What remains becomes the foundation for the next phase. Looking back, ice ages resemble not a single calamity, but a harsh rhythm. Earth sets for itself. a rhythm reminding us that climate is not a fixed background, but a dynamic process. And in such a process, stability, if it exists, is only a short rest between two changes. This makes the present era special in a subtle way, because we are living in an interglacial, a warm window between long, cold cycles. But unlike many interglacials before, this one has lasted long enough and remained stable enough for something unprecedented to form, a civilization dependent on climatic stability. In earlier cycles, when ice withdrew, life returned richer, more diverse. But it did not build long-lasting structures. No cities, no large-scale agriculture, no systems dependent on reliable harvests across generations. Those things require not only warmth, but regularity, something Ice Age rhythms rarely allow. And so, when we look at Ice Age history, we do not only see cold, we see uncertainty. A world where time refuses to stand still, where every state is temporary, and where life must always be prepared for tomorrow to be different from today. From that foundation, the central question of this story becomes clearer. If Earth spent millions of years oscillating between cold and warmth, between ice and water, between expansion and contraction, then what made the present period different? What slowed those oscillations enough for civilization to take root? To answer that, we must step into a very brief yet crucial time in this planet's history. A pause marked not by ice, but by rare climatic stability, and that is the story of the Holocene. About 11,700 years ago, no bell rang to announce a new era. There was no clear boundary line on the ground. There was no moment when the people of that time could stop and say, from today, the world will be different. The ice did not melt overnight. The climate did not reverse in a single season. Earth simply slowed down. And in that slowing, something rare began to take shape. After millions of years oscillating between cold and warm, between expansion and contraction, the Ice Age retreated in the familiar way. But this time, that retreat was not quickly reversed. Sunlight arrived at a better angle for century after century. Summers at high latitudes were long enough for snow to melt completely. Ice did not manage to accumulate again. And when the ice did not return, the world had time to stay still. Scientists call this span the Holocene, a geological epoch, short by Earth's standards, but unusually long compared to many earlier interglacial windows. Global temperatures did not swing violently. Sea level rose and then stabilized within a narrow range. Wind and rain cycles repeated with a rhythm steady enough to be remembered. Earth did not become safe. It became stable enough. The difference was subtle. But for life, especially for humans, it was decisive. During the Holocene, the outside world no longer kept yanking the rug out from under people's feet every few thousand years. Riverlands were not crushed by ice and then drowned again soon after. Grasslands did not open and close too quickly. For the first time in a very long time, the environment allowed repetition. And repetition is what civilization needs more than anything. Humans did not invent agriculture in a single moment of genius. There was no day remembered as the first day of sowing. No individual stood up and changed the fate of the species with a single idea. Instead, there was time, long enough to observe, to experiment, to fail, and to remember. They tried sowing seeds here and saw nothing grow. They sowed elsewhere and watched seedlings emerge only to die in drought. They learned that not every patch of land is the same, that soil near a river is different from soil on higher ground, that the shade of a large tree can help retain moisture, but can also steal light. Those lessons were not written down. They were repeated season after season inside collective memory. Gradually, they realized rain did not arrive entirely at random. That certain times of year, the sky became heavy with water, that the wind shifted before the rains came, that small signs, low clouds, humid air, the behavior of birds and animals often appeared in a familiar order. But those realizations only mattered if the world did not betray them too often. They watched the river floods. At first, there was fear, rising waters that swept everything away. But then came understanding water does not only destroy it, leave silt behind. And silt makes the soil richer. When floods receded with a relatively steady rhythm, people began to wait for them instead of running. They learned to sow after the flood, not before. They learned to estimate water levels by the mud line on stones, by the watermark on tree trunks. This knowledge did not come from abstract reasoning. It came from recurrence. One correct season is not enough. 2 correct seasons could still be luck. But when something holds true year after year, it begins to become practical trust. And that trust allows humans to do something crucial, to invest effort today for the benefit of tomorrow. A seed in that sense is not only a biological object, it is a promise. A promise that if it is sown at the right time, under conditions familiar enough, it will sprout. But that promise only has value when the outside world does not change the rules halfway through, when next season still arrives, much like the previous one. When rain does not vanish entirely, when ice does not return to crush the land that was just planted. In earlier Ice Age periods, the world rarely allowed this promise to be kept long enough. A warm phase could end within a few generations. A new cold cycle could begin before the memory of the last harvest had even been passed on. In a world like that, agriculture is too risky a gamble. Moving, hunting, and short-term adaptation are far safer than binding your life to one fixed piece of land. But in the Holocene, that began to change. Not because humans suddenly became smarter, but because the world began repeating itself. The rainy season came and went within familiar frames. River floods rose and fell in rhythms that could be learned. Temperatures did not slip too far beyond the range crops could endure, and most importantly, those patterns held true for long enough. When truth becomes dependable, humans begin shaping their lives around it. They stayed longer. They built places to store seed for the next season. They protected cultivated land because it was no longer only the present, it was the future. Those choices accumulated generation after generation until a new way of life formed, not as a revolution, but as a habit reinforced over time. Agriculture, therefore, is not humanity's victory over nature. It is synchronization, a silent agreement between humans and the surrounding world. If Earth continues operating with a rhythm steady enough, humans will learn to settle to care and to invest long-term. But if that rhythm breaks, the entire agreement collapses. That is why early observations about rain, about floods, about seeds only truly became valuable when the world was stable enough for them to be correct many times in a row. Not once, not a few times, but long enough for memory to become tradition, and tradition to become the foundation of society. In that moment, humans did not only learn to cultivate, they learned something far deeper. The world, at least for a while, could be trusted. In previous ice ages, even the warmest intervals never allowed that. Climate could reverse within a few generations. Sea levels could rise or fall enough to erase familiar living zones. But in the Holocene, changes, though, still present, occurred within a narrower range, more slowly, and with greater continuity. Within that quiet window, humans began to stay. Not only to shelter, not only to migrate seasonally, but to remain long enough to build structures beyond immediate survival. Homes became more solid, granaries appeared, paths formed, and with them came new ideas of time, of a past that could be remembered, and a future that could be planned. The Holocene did not create civilization through one single shove. It created the background conditions, a climate stable enough to allow accumulation. Accumulation of seed, accumulation of tools, accumulation of knowledge, accumulation of social relationships. And once accumulation became possible, everything else began to follow. Rivers gradually became the fixed axis of life, not because they did not change, but because they changed in ways that could be learned. They curved, rose, fell, sometimes shifted course after many years, yet rarely did so in a way that was utterly unexpected. In the Holocene, the rhythm of the river stopped being a constant threat and became a signal, something observable, rememberable, and predictable. Flood cycles, if they came, began to be recognized as part of the year rather than an accident. People learned water rose by season, then retreated in a relatively steady order. They learned floods did not only sweep away, they also left behind. When water receded, fine silt spread over banks, making soil soft, moist, and rich. What had once been danger gradually became benefit, but only because it repeated steadily enough to be awaited. That waiting was a turning point. Instead of fleeing whenever waters rose, humans began to stay and watch. They marked water lines on stone on tree trunks. They remembered which years floods came early, which came late. They compared this harvest to the previous one. These comparisons did not require writing. They were carried by storytelling, by habit, by small community agreements. When a river's rhythm became familiar, planning became possible. Sow after the flood, harvest before the heavy rains, store reserves for low water years. At first, these plans were simple trial and error. But when they repeated across several successful seasons, they became the right way. And when a right way is passed through generations, it stops being a personal choice. It becomes tradition. Tradition in that sense is stabilized memory. It does not need to be re-explained every time. It is done because this is how we have always done it. But for tradition to form, the outside world must be consistent enough not to constantly refute it. If the river's rhythm changed too often, if floods came and did not recede, if water levels rose and fell without pattern, every tradition would quickly lose value. In the Holocene, that rarely happened on a global scale. As traditions grew in number and strength, they began to bind together. Rules about planting times connected to rules about dividing land. Customs about water connected to customs about cooperation and sharing. Gradually, what had once been personal experience became institutions, social structures, maintained not only by memory, but by agreement. In that process, the river was not only water, it became a clock, a calendar, and a map. Flood rhythms became time markers. Riverbanks became boundaries. Flow became the axis that connected communities. The first roads did not cut through forests or cross mountains. They followed rivers where direction was clear and life was always present. The important thing is rivers still changed. They still eroded banks, still curved, still occasionally caused damage. But in the Holocene, those changes stayed within familiar limits. They were large enough to demand respect, yet stable enough that people did not have to abandon their entire way of life every few generations. It was this balance between variation and familiarity that made long-term plans possible. A house no longer existed only as temporary shelter. A field was no longer for only one harvest. A community no longer lived only in the present. When plans repeat long enough, humans begin to think in chains of years, not only in the next season. And when thinking in chains of years becomes habit, society shifts into a new level of organization. Those plans repeated across generations do not only become tradition and then institution. They become the invisible foundation of civilization, a foundation built not of stone, but of the regularity of water, the recurrence of seasons, and the trust that tomorrow will resemble today enough that what is built will not become meaningless. And in all of this, the river's role was not to give humans control. It was to give them rhythm, a rhythm stable enough for life not only to survive, but to be organized, remembered, and passed on. From those familiar rhythms, human history began to flow in a new direction, slower, deeper, and long enough to leave a mark. What is striking is this: the Holocene is not a paradise. It still has droughts, it still has storms, it still has locally colder or warmer phases. But unlike earlier epochs, these fluctuations did not shatter the entire system at once. They unfolded within a more stable background, allowing societies to recover, to adjust, and to continue. This stability does not mean Earth stopped changing. It means the changes did not exceed the accumulated adaptive capacity of humans. The kinds of shifts that were global catastrophes in earlier eras, large temperature swings, dramatic sea level changes, did not occur with the same intensity in the Holocene. And that not too much is precisely what opened the door to an entirely new way of life. In the Holocene's quiet interval, humans began to record, at first with memory, then with symbols, then with writing. These records did not only preserve events, they preserved rhythm-planting seasons, harvest seasons, ritual calendars, astronomical calendars, all built on the assumption that the world would continue to operate by familiar rules. And in the Holocene, that assumption was often correct. That repeated correctness created trust. Trust allowed humans to invest in things that only matter: long-term levees, canals, cities, law. No one builds a city if they believe that within a few generations it will be crushed by returning ice, or drowned by seas rising under an unpredictable cycle. The Holocene, through its relative stability, made long-term decisions reasonable. But what must be emphasized is this: the Holocene is not Earth's default state. It is an exception, a rare pause in a long history of oscillation. By geological standards, 11,700 years is only a brief moment. But by the standards of civilization, it is the entire story. Every civilization we know, from the first farming communities to complex societies, has existed entirely within the Holocene. They did not overcome ice ages to build their world. They were allowed to build because the ice had temporarily retreated. This truth changes how we view human history. Civilization is not an inevitable result of intelligence or creativity. It is the result of a rare coincidence between human capability and a climate window stable enough for that capability to take hold. The Holocene, in that sense, is not peaceful because danger is absent. It is peaceful because the great forces, the forces that have erased life many times, are temporarily not colliding violently with one another. Earth still moves, but its movements are more balanced. And inside that fragile balance, humans did what they had never before had the chance to do: build a world based on the assumption of stability. Standing inside this pause, it is easy to forget it is an exception. Easy to believe the world naturally works this way. But Earth's deep history whispers a different story, one that reminds us that pauses, like the Holocene, do not last forever, and that stability, when it appears, deserves to be noticed. And that is why the central question of this story becomes more urgent than ever. If the Holocene is a rare exception, if our entire civilization is built inside this pause, then where are we standing within that pause right now? To answer, we must look more closely at why the Holocene is calm and what is holding that calm in place, at least for now. The silence we are experiencing is not a feeling. It does not come from human subjective perception. It is a physical state, measurable, traceable, and explainable, at least in part. When scientists say Earth is in a relatively calm phase, they are not talking about social peace or absolute safety. They are talking about the fact that the largest forces governing this planet are not currently colliding violently with one another. To understand why we have to step back and look at deeper systems that move slowly, very slowly, but determine the rhythm of everything above them. First is Earth's orbit, a motion that seems stable, yet has never truly stood still. This planet does not travel around the sun in a perfect circle, closed and unchanging. Its orbit stretches and contracts over time, sometimes more circular, sometimes more distinctly elliptical. That change happens so slowly over tens of thousands of years that in a single human lifetime, it is almost invisible. But for global climate, it carries profound meaning. When the orbit is more circular, the distance between Earth and the Sun changes less throughout the year. Solar energy received by the planet is distributed more evenly across seasons. When the orbit becomes more elongated, that contrast grows. There are times of year when Earth receives noticeably more energy, and other times when it receives less. This small imbalance, repeated across thousands of years, is enough to decide whether ice will melt or accumulate. But the orbit is only part of the story, Earth's rotational axis. The imaginary line the planet spins around also is not fixed. It tilts relative to the orbital plane, and that tilt oscillates within a certain range. When the axis tilts more, the difference between seasons becomes sharper. Summers, hotter winters, colder. When it tilts, less seasons become gentler, less extreme. This oscillation also unfolds in long cycles lasting tens of thousands of years. And like the orbit, it does not create an ice age in a single moment. Instead, it adjusts how sunlight strikes the planet, especially in the most sensitive regions, the high latitudes near the poles. It is there that the fate of ice is decided, not by how cold winter becomes, but by whether summer is warm enough to melt the ice. If summer is too cool, snow that falls in winter will not melt completely. It accumulates year after year, compressing into ice. And once ice begins to spread, it reflects sunlight back into space, cooling the surface even further. A slow but powerful feedback loop is activated. In deep glacial periods, orbital cycles and axial tilt amplify each other in an extreme direction. Summer sunlight at high latitudes grows weaker. Ice does not melt, and the world gradually slides into cold. But in the current phase, what is striking is that these cycles are not resonating in that extreme way. Earth's orbit is not overly elongated. The axial tilt sits in a middle range. The distribution of solar energy across seasons, especially in the northern hemisphere where most land and ice accumulation occurs, becomes relatively more balanced. That does not mean climate does not change. It only means the largest changes are unfolding more slowly and are not immediately pushing the system beyond a threshold. Summers are warm enough to prevent rapid ice buildup. Winters are cold enough to maintain a familiar rhythm. Earth is not being pulled hard toward a new extreme. From a geological time perspective, this is a temporary arrangement. Nothing in orbital motion or axial tilt suggests this state will last forever. The cycles continue. They are simply passing through a segment where their effects partially cancel one another, rather than adding up. That relative cancellation creates the sense of calm, a calm that does not come from forces disappearing, but from forces balancing each other. Sunlight still shifts. Earth still tilts. The orbit still oscillates, but overall the system has not yet been pushed out of the narrow stable band it currently occupies. And what matters is this: the high latitudes where the expansion or retreat of ice ages has often been decided are presently receiving enough summer energy to keep ice in a controllable state, not melting entirely, but also not spreading uncontrollably. In Earth's long history, moments like this are not common moments when slow cosmic motions inadvertently align to produce a relatively even climatic rhythm. A rhythm gentle enough that the world above ocean's forests and eventually humans can build structures that endure through time. But like every rhythm in Earth's history, it is not a promise. It is simply a balance in motion, quiet, slow, and full of meaning. Not because Earth has stabilized forever, but because the orbital parameters are currently within a zone that allows climate not to slide too quickly toward a new extreme. This is a temporary state, but in recent history, it has lasted long enough to create a sense of calm. Next is the role of the moon, an element often overlooked because it is so familiarly present in the night sky. Yet in Earth's long story, the moon is not merely a satellite. It is a stabilizer, Earth's axis. The invisible line that determines seasons' climate and the distribution of light is not fixed in space. If left alone, it could wobble dramatically, tilting back and forth in unpredictable ways. In a world without the moon, Earth's axis could shift by tens of degrees over relatively short geological intervals. Regions once temperate could become icy. Regions once cold could receive harsh light. Climate would not merely change, it would slide. But the moon, through its gravity, keeps Earth's axis within a far narrower range of variation. It does not lock the axis at one fixed angle. It simply prevents it from drifting too far. That difference is subtle, but the consequences are profound. Earth still has seasons. It still has fluctuations, but those fluctuations are softened. They unfold in cycles, not in sudden flips. Because of that, climate cycles become more rhythmic. Not perfectly predictable in detail, but regular enough for the system to self-regulate. Ice does not suddenly spread worldwide within a few thousand years. Climate does not violently reorient simply because of a random wobble. In deep history, the moon's presence has helped Earth avoid chaotic scenarios that other rocky planets may have experienced. But this stability does not come only from the sky. It is amplified and maintained by another system that covers most of Earth's surface, the oceans. Water has a remarkable physical property of very high capacity to absorb and store heat. That makes the oceans a massive energy reservoir. During day, during summer, during warm epochs, the oceans absorb heat. During night, during winter, during colder epochs, the oceans release heat slowly back into the atmosphere. In this way, extreme temperature swings are reduced. The world does not heat up too fast, nor does it cool down too abruptly. Yet oceans are not a still body of water. They are always moving. Surface currents carry heat from the equator northward and southward. Deep currents, slower but more persistent, return cold water toward the tropics. This is a global heat exchange system, running continuously over thousands of years. In the Holocene, the basic structure of the major ocean circulation, though still subject to local variation, has maintained a relatively stable global connectivity. Heat is not trapped in one hemisphere for too long. Cold is not locked in the other. This exchange helps prevent extreme scenarios in which one half of the planet freezes while the other becomes too hot to sustain familiar ecosystems. The oceans, in that sense, do not make Earth peaceful. They make Earth slower. Slower in how it responds to shocks, slower in how it transmits change, and in a complex system like climate, that slowness is invaluable. It creates lag time for other processes to intervene, adjust, and rebalance. The Holocene's relative stability, therefore, does not rest on a single factor. It rests on a gentle resonance among multiple dampers, an axis held within a narrow range, oceans, distributing heat and currents connecting the world. No part controls the entire system. But when they operate together, major extremes become rarer. What matters is neither the moon nor the oceans were designed to serve life. They simply obey physical laws. But because those laws are interacting in a less antagonistic way in the current period, Earth can maintain a state humans experience as calm. A calm not because the world has stopped, but because the largest forces are holding each other in balance. And once we understand that, we begin to see that the stability civilization depends on is not self-evident. It is the result of multiple systems working at once, slowly, silently, and so far still effectively enough to keep the world from sliding away from its familiar track. The oceans also serve as a carbon buffer. They absorb a large share of atmospheric carbon dioxide, slowing abrupt shifts in composition. In earlier geological eras, when oceans were strongly disrupted by massive volcanism or sudden sea level changes, that regulating capacity broke down. At present, that system is still functioning relatively effectively. Another factor less dramatic, but no less decisive, is the level of global volcanic activity. Earth has never been a quiet planet on the inside. Its crust is always cracking, shifting, releasing energy. Volcanism in that sense is not an exception. It is a normal part of how this planet works. But what matters is not whether volcanoes erupt. It is the scale and tempo of eruption. In Earth's deep history, there have been periods when volcanism was not merely scattered hotspots. It became a dominant mechanism operating continuously on a supercontinental scale. Eruptions lasting hundreds of thousands, even millions of years, covered vast stretches of the surface in enormous lava flows. More importantly, they released colossal quantities of greenhouse gases into the atmosphere, enough to push global climate into a completely different state. In those times, climate had no time to adjust. Temperatures rose quickly. Oceans warmed and changed chemically. Feedback loops triggered in succession. Not because volcanoes intended to destroy life, but because the climate system was forced to change faster than it could absorb. The Holocene is different. In this period, Earth still erupts. Volcanoes still occur on land and beneath the seafloor. Ash still falls. Gases are still released. But most events are episodic, short-lived, and not synchronized on a global scale. They can produce local impacts, sometimes regional, sometimes widespread, but rarely long enough and large enough to tilt the entire climate system. When major eruptions occur in the Holocene, they often leave clear marks in human history. Cooler summers, failed harvests, hazy skies for a few years. But then climate recovers. Oceans absorb part of the gas. The biosphere adjusts. Ash settles. Familiar cycles gradually return. This reveals a key difference in the Holocene. Volcanism has not held the commanding role in shaping long-term climate. It is a factor within the system, not a force dragging the whole system into a new state. The climate retains the capacity to absorb shocks rather than being carried away by them. That difference does not come from Earth becoming gentler. It comes from tempo. When eruptions do not stack upon one another for long periods, when they do not occur simultaneously across vast regions of crust, regulating mechanisms, ocean's biosphere, the carbon cycle have time to respond. Not fast, but enough. In a complex system, speed can matter as much as intensity. A moderate change, sustained over a long time, can have deeper consequences than a large shock that fades quickly. The Holocene so far has avoided eruption chains long enough to surpass the climate system's self-regulating threshold. So when we say Earth is calmer now, we do not mean the internal forces have vanished. We mean they are being dispersed through time rather than compressed into short, violent intervals. Volcanoes still breathe, but they do not breathe all at once, not for too long, and not strongly enough to suffocate the entire system. That relative quiet allows climate to keep its familiar inertia, not perfectly stable, but not pulled off course in a short time. And that space-time for the system to absorb and adjust is what has allowed the Holocene to last long enough for civilization to take root. From a distance, the difference between violently unstable epochs and the present is not whether Earth is active. It is whether those activities overlap, persist, and resonate with one another. In the Holocene so far, they mostly have not, and that is another reason this pause, fragile as it is, continues. We should also mention the absence of major asteroid impacts in recent time. In Earth's history, such impacts are not rare on 100-million-year scales. But in the Holocene, there is no evidence of an event large enough to collapse global climate. No sky darkened for years. No food chain shattered abruptly. The quiet from space measured against long history is an important factor in the present moment. Finally, there is the biosphere itself. After thousands of years of relative stability, the planet's large ecosystems have developed high complexity. Forests, grasslands, oceans, wetlands all participate in climate regulation cycles, storing carbon, controlling water, vapor, stabilizing soil and runoff. These systems are not invulnerable, but when functioning fully, they reduce the amplitude of environmental shocks like dampers in a massive machine. What matters is none of these factors operates alone. Earth's current calm does not come from a single cause, but from the temporary alignment of many conditions. The orbit is not too extreme. The axis is stable. The oceans are connected. Volcanism is not sustained at catastrophic scale. Space is quiet. The biosphere is mature enough to self-regulate. None of these is permanent. But when they coexist, the world becomes stable enough. And here's the key point. Earth does not choose calm. It does not aim for stability as a goal. The present silence is like many huge gears that happen to mesh for a while. As long as they remain engaged, the machine runs smoothly. When one gear shifts far enough, the rhythm changes. By geological standards, we are living inside a narrow window. Narrow, not because it is about to close immediately, but because in deep time, windows like this rarely last long. They allow complex life and long-term structures to form, and eventually give way to another state. The current calm, therefore, is not a promise. It is a condition. A condition that has allowed humans to build, accumulate, and rely on the repetition of the outside world. But like every condition in Earth's history, it endures only as long as the foundational forces remain in balance. And once we understand that the next question is no longer whether Earth will change, the question becomes, we as a civilization built entirely inside this pause, how well do we understand it? That is the moment when the story no longer belongs only to geology or climate. It begins to touch the human. There is a quiet paradox at the center of this story. While Earth's great forces orbit axial tilt, oceans, volcanoes are temporarily holding one another in balance, humans rarely feel calm. The outside world is more stable than it has been through most of the planet's deep history, but the inside world of human societies is not. The Holocene gave humans a climate steady enough to build upon, but it did not give them serenity. On the contrary, within that pause, a new kind of instability emerged. Instability created by humans themselves. To understand this, we need to remember that humans did not evolve in a stable world. Most of our biological history unfolded against a backdrop of constant oscillation climates, shifting food sources, migrating habitats, opening and closing. In such a world, vigilance is an advantage. The ability to react quickly to change is what keeps a group alive. The human brain was shaped inside that very context, a world rarely stable long enough to allow subjectivity. It was not forged to seek peace. It was forged to detect deviation, to notice that something is off before it becomes obvious, to prioritize survival over the feeling of safety. In the environments where humans evolved, Danger rarely arrived with a posted notice or a clear warning. It came through very small signs, a strange sound in the undergrowth, an unnatural silence in the forest, a familiar path that today carries no trace of the herd. Those signals are uncertain, but ignoring them could cost a life, so the brain learned to react before it fully understood. A wrong assumption believing there is danger when there isn't only wastes energy, but the opposite assumption believing everything is fine when danger is coming can end everything. Over hundreds of thousands of years, nature favored individuals who were willing to worry early, stay alert early, and prepare for the worst, even when the evidence was still vague. A dry season that lasts longer than usual is not merely an inconvenience. It can signal the collapse of a food source. A herd disappearing is not merely random. It can be a sign of a new predator or of an environmental shift already underway. In those contexts, waiting for certainty is often too late, so the brain became a prediction machine. It continuously simulates worst-case scenarios. It asks questions before answers exist. It prepares for loss before loss arrives. Anxiety across most of history was not a psychological burden. It was a survival tool. But that tool was designed for a world where change came from nature, slow, irregular, and often local. When we moved into a world more stable in climate but more complex in society, the tool did not disappear. It kept running even as the thing it was searching for changed. In the Holocene, many ancient threats diminished. Predators were less likely to kill directly. An ice age would not return within a single lifetime. Harvests became somewhat predictable, but the brain was not updated to recognize that the world had changed. It still scanned the environment, searching for anomalies, searching for signs of collapse. And if it could not find them, it generated scenarios to fill the blank space. This creates a subtle paradox. When real danger decreases, the feeling of insecurity does not necessarily decrease with it, because the brain does not measure safety through objective data. It measures through the absence of reliable signals that everything will remain stable. And in evolutionary history, there was never such a signal. So, even in a relatively calm world, humans prepare for tomorrow as if it might carry a sudden shock. They stockpile, they compete, they plan for scenarios that have not happened. Not because they are pessimistic, but because their brains were built to distrust silence. Silence in deep time was often only a short rest before another upheaval. And the brain, loyal to that history, keeps whispering, "Be careful, be ready, assume the bad before it has time to appear." In that context, anxiety is not a design flaw. It is an evolutionary inheritance, a reflex sharpened over hundreds of thousands of years of instability, now living inside a rare pause, and still not yet able to trust that the pause might last. But as we entered the Holocene, the outside world began to move to a different rhythm. Climate no longer reversed violently within a few generations. Natural cycles became more regular. Risk still existed, but it was rarely global. Earth, by geological standards, was quiet. Humans were not. In a world stable enough for accumulation, humans began to do what they had rarely had the chance to do before: expand. Populations grew, cities formed, networks of exchange stretched across hundreds, then thousands of kilometers. Each new layer of organization solved certain old instabilities, yet, at the same time, it created new ones. Agriculture reduced dependence on hunting, but it created dependence on crops. Cities concentrated resources, but they created dependence on distribution systems. Technology reduced local risk, but it connected risks together so that a small failure could spread outward. In that process, humans gradually detached their experience from natural rhythm. When harvest failed, the cause was no longer simply rain or sun, but markets policy or conflict. When water grew scarce, it was not only drought, but dispute. When instability arrived, it rarely came from Earth. It came from the way humans organized their lives. The paradox is here: the baseline environment became more stable than ever, and yet the human sense of instability intensified. Not because Earth suddenly became more dangerous, but because the way humans lived inside that stability changed the very nature of risk. A crucial part of this paradox comes from civilization's own success. Throughout the Holocene, humans learned how to reduce direct threats from nature. Dams controlled floods, granaries softened local famine, shelter medicine and technology reduced vulnerability to cold heat and disease. On the surface, the world became safer. Fewer people died from severe weather. Fewer communities were erased by a single failed season. But that safety did not come for free. It was built with systems that grew increasingly complex, and that complexity changed how risk operated. In a simple society, risk is often local. A river flooding affects the riverside. A dry season affects a particular region. The impact is large, but the scope is limited. And when risk passes, the system can recover without dragging the entire world with it. In modern systems, everything is more tightly connected. Economies depend on supply chains stretching across continents. Technology depends on electrical grids, data networks, and infrastructure that must run continuously. Politics depends on trust information and institutional stability. These systems work efficiently when every link holds. But precisely because of that, they become fragile in a new way. A small malfunction no longer stops where it begins. It spreads. A disruption in transport can affect production elsewhere. A technical error can paralyze services at a wide scale. A bad decision can trigger chain reactions amplified by dense networks. In such a world, risk does not need to be large to become serious. It only needs to be placed in the right location. This changes how humans experience instability. In the past, threats often came from clear forces. Storms, cold, drought, hunger. They were tangible, observable. Preparations were possible, at least to some extent. Today, many dangers are abstract. They exist inside the system, inside interdependence, inside causal chains, so long they are difficult to trace. And the human brain, designed to respond to specific direct threats, struggles to locate this new kind of risk. When it cannot clearly point to what is threatening it, the sense of unease does not vanish. It spreads. It becomes a background state rather than a temporary reaction. Civilization success creates another paradox as well. When risk becomes rarer, each disruption feels more severe. In a world that frequently faces disaster, people learn to accept loss as part of life. In a world designed to run smoothly, any interruption feels abnormal and therefore more worrying. Baseline stability raises expectations of continuous stability. When that expectation breaks even briefly, the psychological response can be far stronger than responses to familiar risks in the past. Not because the danger is larger, but because faith in the system has been shaken. Here, instability no longer comes from nature, but from the complexity of the very solutions humans built to escape nature. The systems that keep us safe from cold, hunger, and disease also force us to trust their continuous operation. And that trust, once challenged, generates an entirely new kind of anxiety. So the rising feeling of instability is not necessarily a sign that the world is collapsing. It is a sign that humans are living inside a structure where risk has changed shape from direct and obvious threats to indirect, contagious, and hard-to-predict dangers. In such a world, feeling uneasy is not necessarily irrational. It reflects a deeper truth. When systems grow large and interconnected, enough surface calm can conceal deep vulnerabilities. And it is at that intersection between an Earth that is relatively quiet and a society that is increasingly complex that the human paradox continues to exist. Not because we do not understand the world, but because we have built a world where stability and fragility coexist. The Holocene allows humans to trust tomorrow. But humans with brains trained in instability do not easily trust. Instead, they continually prepare, plan, compete, accumulate, expand further, even when the current foundation is already enough. Earth's silence does not make humans stop. It makes humans accelerate. And when speed increases, the perception of risk changes. In a slow world, danger often comes from rare, massive forces. In a fast world, danger can come from small deviations that spread through dense networks. This creates a continuous tension, not because Earth is threatening us, but because human-made systems do not permit rest. Another paradox lies here. Humans understand Earth more than ever before. They can measure temperature, sea level, atmospheric composition. They can read millions of years of climate history through ice cores and sediments. But the more clearly they understand the fragility of natural balances, the more they recognize that the current pause is not guaranteed. That knowledge does not bring absolute reassurance. It brings a new vigilance. Not vigilance against predators or ice ages, but vigilance toward our own impact on a system that is already fragile. So, while Earth is in a relatively calm phase, humans live with the feeling that everything could change very quickly. Not because the planet is about to do something unexpected, but because humans have become a force large enough to change the very stability they depend on. This paradox is not moral. It does not say humans are wrong. It simply reflects a fact. A species that evolved in instability, when placed inside stability, will not automatically become serene. Instead, it will continue to behave as if instability is always just ahead. And perhaps that is why this story is not only about Earth. It is about the relationship between a rare pause and a species that has never learned how to slow down inside that pause. When we look at the Holocene, we do not only see a planet that is quiet. We see a species experimenting with living in that quiet, sometimes skillfully, sometimes clumsily, always carrying the reflexes of an unstable past. And that brings us to the next question. Not whether Earth will change or not, but what are we doing with the calm we have been given? To understand how rare the present moment is, we need to do something that does not come naturally to the human brain: expand the scale of time. Not a few years, not a few centuries, but millions of years. Only then does the calm we are experiencing reveal its true shape, not as a default state, but as a brief exception. Across more than 4.5 billion years of Earth's history, this planet has rarely held a climate stable enough for long periods. Most of the time, the world oscillates much hotter than today, or much colder. Seas rise and fall. Ice spreads and melts. Continents merge and split apart. Those chains of fluctuation are not accidents. They are the baseline rhythm. If we compressed all of Earth's history into a single imaginary year, the existence of modern humans would occupy only the final minutes of New Year's Eve. And the Holocene. The calm interval long enough for civilization to form would be only a few seconds within that. Not a season, not a month, a moment. This does not mean the Holocene is unique. Earth has had stable intervals before, but they tended to occur in very different contexts, when life was simpler, when no species was building systems tightly dependent on climatic repetition. Never before the Holocene has an entire complex civilization been built entirely inside such a climatic pause. What makes this moment remarkable is not only the stability, but the degree of coincidence. Human cognitive capacity, the accumulation of technology, the scale of population, the reach of social networks. All of these appeared at the same time as a climate steady enough to support them. Not earlier, not later. A rare intersection of many conditions. In deep history, intersections like that are not common. When climate remains stable for millions of years, life is given something extraordinarily generous time without urgency. In such intervals, there is no constant pressure to reinvent survival strategies every few generations. Energy can be spent not on fleeing collapse, but on exploring possibility. Species spread outward, occupy niches, and slowly refine themselves. Diversity increases not because life is racing forward, but because it is allowed to linger. In these long, stable stretches, evolution becomes expansive rather than defensive. Organisms experiment with form, metabolism, size, and behavior. Some grow larger, others smaller. Some specialize intensely. Others remain flexible generalists. Forests deepen. Reefs thicken. Food webs become layered and intricate. Over vast spans of time, life fills not just space, but roles, predators, grazers, decomposers, symbionts, each linked to the others in delicate equilibrium. Yet even in this abundance, life does not build in the way humans understand building. It does not accumulate memory outside of genetics. It does not store surplus for futures it cannot imagine. It does not create structures designed to outlast bodies, generations, or ecological cycles. A coral reef may persist for thousands of years, but it is not a plan, it is a consequence. A forest may stand for millennia, but it is not a project. When conditions shift, these systems do not argue with reality. They respond, adapt, migrate, or vanish. This is because biological logic operates on replacement, not preservation. Individuals die so populations can adjust. Traits spread only as long as they remain useful. There is no concept of legacy, no attempt to freeze a successful configuration against future change. Stability allows complexity, but it does not produce intentional continuity. In such worlds, there is no accumulation of institutions, no externalized memory, no social scaffolding designed to resist time. When an organism dies, what it knows dies with it, except for what has been encoded slowly, imperfectly into DNA across countless generations. Learning is biological, not historical. The past is not remembered, it is selected. And when conditions eventually change, as they always do, life does not mourn what is lost. It does not preserve ruins. It does not attempt to restore a previous state. It simply moves on, reshaped by pressure. Entire lineages disappear without ceremony. Others radiate into the emptied spaces. From the perspective of life itself, nothing is broken. The system continues. This is why long periods of climatic stability in Earth's deep past produced abundance, but not civilization. They produced richness without memory, complexity without permanence. Life flourished, but it did not anchor itself. It flowed with time rather than pushing against it. What makes the human moment unusual is not that stability exists, but that stability coincides with a form of life that tries to remember, tries to preserve, and tries to build structures meant to endure beyond biology. That impulse does not emerge automatically from stable conditions. For most of Earth's history, stability simply meant that life had more room to change slowly. Only very rarely does stability arrive at the same time as a species capable of accumulation beyond the body. capable of storing knowledge, coordinating across generations, and imagining futures longer than a single lifespan. And that coincidence, not stability alone, is what makes the present moment fundamentally different from almost everything that came before. Conversely, when life reaches a level of complexity sufficient to build, sufficient to remember, transmit, and accumulate, climate often does not stay still long enough. Oscillatory cycles return. Ice advances and retreats. Seas rise and fall. The world does not allow long-term structures to take root. Life can persist, but whatever is built will soon be forced to be abandoned. The Holocene sits precisely between those two extremes. It does not last millions of years like ancient stable epochs, but it is not quickly interrupted by violent reversals the way many earlier interglacial intervals were. It is stable enough to allow accumulation, but not long enough for Earth to lose its dynamic nature. That balance is extremely subtle. The Holocene does not make the planet static. It only slows the oscillation to a pace humans can keep up with. Slow enough that memory is not erased within a few generations. Slow enough that failed experiments can be repaired rather than buried completely. Slow enough that social structures, language, law, technique have time to strengthen themselves. For that reason, this moment is not the natural peak of some inevitable process. It is not a point Earth was moving toward. There is no evidence that this planet is designed to eventually produce a stable, enduring civilization. The Holocene is not the outcome, it is the condition. It is like a window opening, not too wide, not too long. A window that lets light in long enough for something new to form. But the window itself is not a permanent wall. It does not hold the world in place. It only temporarily allows the world to slow down. If you stand too close, if you live an entire life inside that window, it is easy to mistake it. Easy to believe this is the normal state of things. That a stable climate is self-evident. That a relatively fixed sea level is a natural foundation. That the world simply operates this way. But that is an illusion produced by a short view. When you step back beyond the scale of a human lifetime of written history, even of all human history, the true shape of this moment becomes visible. That window is set between two walls of time. One wall is the past, where volatility is the baseline rhythm. The other wall is the future, where unfinished cycles will continue along their trajectories. Those two walls do not rush toward us. They move very slowly, so slowly that over many generations humans can believe they do not exist. But in Earth's deep history, slow motions always win. Not through drama, but through persistence. The Holocene, in that sense, is not a permanent foundation. It is an intersection where the complexity of life meets the temporary stability of climate. A rare meeting, but one that is not guaranteed to repeat in the same way. This does not make the present moment meaningless. On the contrary, it gives it weight. Because what is built within a fragile window carries a different meaning than what is built on an eternal foundation. It demands attention, understanding, and a degree of humility before deep history that very few species have ever had the chance to reach. The Holocene does not promise it will remain. It only permits. It permits accumulation. It permits memory. It permits humans to ask questions about their own position within this vast timeline. And precisely within that temporary permission, the present moment becomes worth contemplating, not because it is immortal, but because it is rare, thin, and long enough to be recognized. The fragility of this moment does not come from a feeling of imminent collapse. It comes from probability, the probability that orbital cycles axial tilt oceans, and Earth's internal systems will continue not to resonate in an extreme direction for long enough. In the past, that probability has rarely lasted forever. Stable intervals ended not because of a mistake, but because the next cycle arrived on time. Seen this way, the Holocene is not a permanent foundation. It is a temporary straight segment on a long, rugged curve. It does not promise it will continue. It is simply happening. This places humans in a very particular position in Earth's history, not as rulers, not as central characters, but as witnesses. Witnesses to a rare calm interval, long enough to remember, clear enough to measure, and fragile enough that it could disappear from the lived experience of future generations. This rarity is not threatening, it is orienting. It reminds us that what we call normal stable harvests, relatively fixed sea level climate within familiar bounds, are in fact special conditions, not the planet's general rule. And because they are special, they deserve to be recognized. In deep history, this has happened again and again. A species appears under favorable conditions. It spreads. It adapts perfectly to the world it inhabits. For thousands, tens of thousands, sometimes millions of years, everything seems to function properly. Then the baseline conditions change. Climate drifts. Food sources vanish. Habitats shrink. And that species disappears not because it was weak, not because it was wrong, but because the world has no obligation to hold its shape until adaptation is complete. In deep time, no species ever knew this before it happened. Change arrived as a reality, not as a possibility. There were no signs interpreted correctly, no long-term memory for comparison, no way to know that what was happening was only a temporary phase within a much longer sequence. Humans are the first exception, not because humans are smarter in any absolute sense, but because humans, for the first time, live inside a pause long enough to record the past of their own planet. They drill deep into ice, read sediment layers, analyze the chemistry of rock and coral. From traces that have no memory, they reconstruct a history that no organism before them could access. Ice layers do not tell stories, but they preserve the breath of ancient atmospheres. Sediments have no consciousness, but they record the rising and falling cycles of oceans. When those fragments are placed side by side, a picture appears. This world is always changing, and the stability any species experiences rarely lasts forever. What makes the present moment different is not only its calm, but the fact that the calm is recognized. Humans do not merely live inside a pause, they know it is a pause. They can place it on a multi-million-year timescale and see how thin it is. That recognition has never existed before. Across Earth's history, species responded to change after it happened. Humans are the first species capable of recognizing the temporary nature of baseline conditions while still living inside them, not by intuition, not by myth, but by data accumulated from things that are no longer alive. That creates an entirely new situation in the history of life, a species that depends on stability and yet understands that stability is not the planet's default state. A species that builds long-term systems and yet knows the natural foundation supporting them has vanished many times in deep time. This recognition does not grant absolute control. It does not allow humans to command orbital cycles or halt the movement of continents. But it changes our cognitive position from being swept along by volatility to understanding that we are living inside a temporary exception. And because of that, the present moment is not only rare, it is rare in a conscious way, a calm interval whose fragility is seen measured and discussed while it still exists. This has never happened in Earth's history because no species before had enough time, enough tools, and enough distance to do it. In deep history, life always moved ahead of understanding, adapted first, realized later, if it still existed to realize anything. For the first time, understanding moves ahead. Not to prevent all change, but to be aware that change is certain, even if its pace is slow enough that a single lifetime might not feel it. This moment, then, is not tragic. It is witnessing a species standing inside a rare, calm interval, able to see both behind and ahead, on a timescale no organism before could see. And in the long history of a planet that never stops changing, recognizing that one is living inside an exception may be the closest life has ever come to the concept of awakening. The fragility of this moment does not lie in the fact that it is about to end. It lies in the fact that it is not guaranteed. It exists as long as the foundational forces have not pushed the system out of a narrow band of balance. And in deep history, narrow bands of balance are always temporary shelters, not permanent homes. But perhaps that is exactly why this moment carries a deeper meaning, not as a warning, but as an opportunity for awareness. An opportunity to understand that the stability we live inside is not self-evident. It is a rare condition and therefore valuable. From a distance, we do not see a world standing still. We see a planet allowing a slower rhythm temporarily. A rhythm slow enough for humans to think about their own position within deep time. And from that thinking, the story reaches its final chapter. Not to deliver a conclusion, but to pose a simpler, quieter question. When we are given such a rare pause, what do we choose to do with it? If the present moment is rare, if the stability we are living inside is not Earth's default state, if humans for the first time are capable of recognizing that while we are still inside the quiet, then the next natural question is not what should we fear, but rather, what should we understand? Understand first that stability is not a promise. It is not a reward. It is not the inevitable result of evolution or of history. In Earth's deep history, stability has always been a temporary condition, a state that appears when multiple foundational forces happen not to resonate in an extreme direction. Earth has never signed an agreement with any species promising that the world will hold still while they adapt. There is no contract written into the physics of the planet, no clause that protects complexity once it appears. The systems that shape Earth operate without awareness of who lives upon them or how much has been built. Orbital cycles do not recognize agriculture. They do not adjust because fields have been planted or because harvests depend on familiar seasons. The slow wobbles and stretches of Earth's path around the sun continue according to gravitational mathematics, alone, altering the distribution of sunlight over tens of thousands of years, whether crops exist or not. To these cycles, wheat and forests, ice sheets and deserts are all equally invisible. Ocean currents do not care about cities. They move heat and salt according to temperature gradients, wind patterns, and the geometry of continents. When currents shift coastlines, cool or warm, rains fail or intensify, fisheries move, and entire regions are transformed. None of this happens in response to human settlement. Ports, trade routes, and coastal societies may rise in harmony with these flows for a time, but the currents themselves never slow to accommodate them. Tectonic plates do not pause because a civilization is growing. They drift at the pace set by the planet's interior heat, colliding, subducting, and pulling apart continents over millions of years. Mountains rise, basins sink, volcanic arcs form. Earthquakes release stored strain. These processes do not wait for cities to be finished, temples to be preserved, or populations to relocate. When stress exceeds a threshold, the ground moves regardless of what stands upon it. This planet runs on its own laws written in gravity, thermodynamics, and chemistry. Those laws are consistent, but they are not considerate. They do not aim toward stability, nor do they aim toward disruption. They simply unfold. Sometimes by coincidence, rather than design, these unfolding processes align in ways that slow change. Orbital parameters reduce extremes. Currents distribute heat evenly. Tectonic activity avoids prolonged global upheaval. In those moments, stability emerges. But allowing is not the same as guaranteeing. Stability is not a promise made to life. It is a temporary configuration of forces that happens to persist. It lasts only as long as the underlying parameters remain within a narrow range. When one element drifts far enough, when an orbital cycle shifts phase, when a current reorganizes, when tectonic or volcanic activity intensifies, the balance dissolves without warning or intent. From Earth's perspective, nothing has gone wrong when this happens. The planet has not failed, it has simply continued. What appears to life as disruption is at the planetary scale, ordinary motion resuming after a pause. This is why the persistence of stable conditions should never be mistaken for protection. Earth does not shield its inhabitants from change. It merely at times delays it. And every structure built during those delays, every ecosystem, every society, every civilization exists on borrowed time, measured not in moral terms, but in the slow arithmetic of planetary processes. To live on Earth is not to be guaranteed continuity. It is to inhabit a moment when continuity happens to be possible. Understanding that does not diminish the value of the present moment. On the contrary, it places this moment at its proper scale, not inflated into a peak, not dismissed as a trivial detail. A span of time long enough for complex life to accumulate, steady enough that memory is not erased within a few generations, yet thin enough that it cannot be treated as permanent. Understand next that human unease is not necessarily a reaction to an immediate hazard. It is the evolutionary inheritance of a species formed inside instability. The human brain was not designed to rest in prolonged calm. It was designed to scan for deviation, to predict threat before threat takes visible form. For most of our history, that reflex was a survival advantage. When the outside world becomes more stable, that reflex does not disappear. It keeps running even when its target has changed from predators and weather to social, economic, and technological systems. Anxiety is no longer anchored to a single concrete danger. It becomes a background state. Understanding this helps distinguish between felt unease and the planet's underlying reality. Not to deny risk, but to avoid projecting ancient reflexes onto every modern fluctuation. Not every perceived instability reflects a major shift in Earth's system. And not every quiet interval is a sign of permanent safety. Understand more deeply that humans are not only observers of deep history. We do not stand outside the cycles we study. We live inside them. For the first time in the history of life, a species is both capable of reading the planet's past and large enough, connected enough to become a factor that can influence that rare foundation of stability itself. This does not turn humans into controllers, but it does make humans conscious participants. Not because we can stop Earth's motion, but because we can understand that every large-scale action unfolds inside a narrow window of balance. Understanding that does not lead to panic. It leads to humility. Humility before timescales far beyond a human life. Humility before the fact that what we call normal is in truth a set of highly special conditions. Humility before the reality that civilization is not built on unchanging bedrock, but on a moving foundation that has temporarily slowed. In deep history, this is true not only of biological species, it is also true of civilizations. Societies that once flourished under favorable conditions, stable climate, abundant water, fertile land, Smooth exchange networks did not vanish because they were wrong. They vanished because the conditions that allowed them to exist did not remain in the same shape. No ancient civilization collapsed in a world that stood still. For most of human history, civilizations emerged within relatively stable intervals. Rivers had familiar flood rhythms. Rainy seasons repeated with enough regularity. Coastal lands maintained sea level within workable bounds. Under such conditions, humans learned to build. They farmed. They accumulated. They organized society around quiet assumptions that tomorrow would be similar enough to today, that what was built today would still matter. Those assumptions were not mistakes. They were reasonable assumptions in the context people lived in. But history shows that when that context shifts, even slowly, even without drama, civilizations often cannot adapt at the same pace. Not because they lacked intelligence, but because social systems are always slower than natural systems. A river changes course over a few centuries. An aquifer gradually empties across many generations. A chain of dry seasons stretches a few years longer than the familiar norm. These changes are small enough not to trigger immediate panic, yet large enough to erode the foundation society has depended on. In many cases, civilizations continue operating as if baseline conditions are still intact. They adjust in parts. They build more infrastructure. They expand administration. But systems built for a stable world rarely have the capacity to restructure quickly when that world begins to turn. And when adjustment comes too late, collapse does not arrive as a single instant catastrophe, but as a prolonged retreat of the ability to sustain. Cities are not destroyed overnight. They are abandoned. Canals are not flattened. They slowly run dry. Centers of power are not immediately overthrown. They gradually lose the ability to govern as resources no longer match the structure they once maintained. There is no judgment in that process. No simple moral lesson in the easy sense. Only time continuing to move and baseline conditions continuing to drift. What makes modern humans different is not that we are immune to this rule. It is that for the first time we can see the rule while still living inside a period of stability. We do not only look at ruins, we look at time series. We know that many ancient civilizations did not collapse because of a single war, but because of prolonged shifts in climate and environment. We know that those shifts often unfolded within a range too subtle for a single lifetime to grasp, yet large enough to break balance across many generations. This creates an unprecedented cognitive difference. Modern humans do not only know that civilizations have disappeared, we know why they disappeared, and more importantly, we know that the cause is not purely exceptional. It is tied to how complex societies depend on the stability of baseline conditions. We know that stability has a history. It appears. It lasts. And in the past, it has always ended not on a fixed schedule, not by human will, but through the continuation of cycles larger than any society. This does not make the present fragile in an emotional sense. It makes the present clearer. Clear that what we call normal, predictable harvests, relatively stable sea level climate within familiar bounds, is in fact a set of highly special conditions in human history. Earlier civilizations did not have this advantage. They could not place their experience inside a tens of thousands of years context. They did not know that small fluctuations they were witnessing might belong to a longer trend. They reacted when consequences had already taken shape. Modern humans, for the first time, can recognize the temporary nature of stable conditions. While those conditions still exist, not by intuition, not by legend, but by data accumulated from things no longer living sediments, ice fossils, chemical traces in rock and ocean. This does not allow us to avoid every fluctuation, but it allows something subtler, not confusing temporary stability with permanence. Ancient civilizations were not complacent in a moral sense. They simply had no other option. They lived in their world with the information they had. We live in a different world, not because Earth has changed its nature, but because our capacity for awareness has expanded beyond the timescale of any single civilization. In deep history, no civilization has ever built complex systems, while simultaneously understanding that the baseline conditions enabling that building are not Earth's default state. No society has ever lived inside a quiet interval, while also knowing that the quiet interval has a beginning, and by every precedent may also have an end. This does not place humans above history. It places us inside history, but with an unprecedented level of self-awareness, not to fear, not to claim control, but to understand that the existence of civilization is always bound to conditions it did not create and cannot fully command. In that long current, modern humans are not an exception to the rule of change. We are only the first species to know we are not an exception, and to know it while there is still time to reflect. And that reflection in Earth's deep history is something entirely new. This awareness does not grant the power to evade every fluctuation, but it grants a cognitive position that has never existed before a species living inside a quiet interval, while understanding that quiet is not the default state. This changes the way we see time. Instead of treating the future as a straight line extending from the present, it becomes an open region where unfinished cycles are still moving forward at a pace slower than a human life. Instead of treating the past as a chain of mistakes already surpassed, it becomes a map of conditions that once existed and then vanished. Understanding this also changes the way we see progress. Progress is no longer the act of rising above nature. It becomes the act of moving with the rhythm of a dynamic foundation, not trying to freeze the world into an ideal state, not believing every system can expand infinitely inside a finite window. Not fear, but understanding. Understanding that the Holocene is not a reward for human intelligence. It is a context, a rare context. And context in Earth's history is always what changes. But to understand context while it still exists is a privilege no species before has ever had. Understanding that fragility is not a threat. It is the natural property of any system that persists over long time. What is sustainable is not what is unchanging, but what knows what conditions it is living within. Another key factor often overlooked when we look back at the history of civilizations is the lag between nature's change and society's response. These two systems do not run at the same rhythm, and that mismatch of rhythm has shaped the fate of many societies in the past. Nature changes on timescales unfamiliar to human experience. A river can shift course over a few centuries. An aquifer can decline over dozens of generations. A rainy season can drift slowly year by year, so that each generation feels only a slight difference compared to what their ancestors remembered. These changes are not loud. They do not carry the shape of instant catastrophe, but they are continuous and cumulative. Human society, by contrast, is built on structures with great inertia. Traditions, institutions, governance systems, and collective beliefs are not designed to change quickly. They are designed to preserve stability under familiar conditions. When the world behaves according to the assumptions that formed them, that is an advantage. But when baseline conditions begin to drift, that same inertia becomes a barrier. The problem is not that society fails to observe change. In many cases, people recognize clearly that something is different. Less rain, longer dry seasons, more unpredictable water. But moving from recognition to restructuring an entire system requires time, consensus, and resources, things that often appear only when the crisis has become undeniable. In that lag, societies often do what is most rational in the short term: adjust in parts, build more canals, expand cultivation into new zones, increase control and administration. These measures can work for a while, but they are usually designed to extend the old state, not to adapt to a wholly new one. When nature's drift passes a certain threshold, partial adjustments are no longer enough. But by then, society has invested too deeply in the old structure to pivot quickly. Collapse, if it comes, happens not because people did not understand, but because they understood when time was no longer on their side. This explains why so many civilizations did not collapse in a dramatic sense. They slid. Population declined. Cities shrank. Networks contracted. There is no single moment you can point to and say, this is when everything ended. There is only a long interval in which society's ability to sustain itself gradually fails to keep pace with the rhythm of environmental change. Modern humans, for the first time, can see this lag phenomenon as a pattern, not merely as separate stories. We know stability does not vanish in a day, but we also know societies rarely restructure at the same speed that baseline conditions can change. This understanding is not meant to produce fear. It only places a very quiet fact where it belongs in deep history. Nature does not need to change quickly to outrun society's capacity to adapt. It only needs to change steadily and long enough. And it is precisely in that lag between a world that is drifting and a society still accustomed to its old shape that history has often turned in a different direction, not because of moral failure, but because rhythms no longer matched. Seen this way, the present moment does not carry the color of tragedy. It carries the color of witnessing a species given enough time to build, enough knowledge to recognize the rarity of the conditions that enabled that building, and enough awareness to know that this recognition itself is an unprecedented step in the history of life. When this story closes, what remains is not fear of an uncertain future, but a very slow settling. A gentle realization that we are living inside a rare, calm interval in Earth's history, and that understanding this while it is still happening may be the most important thing this moment offers us. Not to fear, not to control, but to understand, and from that understanding, to know where we stand inside a timeline longer than any civilization. And as this story slowly comes to a close, perhaps what remains is not a certain conclusion, because Earth's history does not give us conclusions like that. It does not say, this will last, and it does not say, this is about to end. What Earth's history leaves behind is only context, a context that is very particular, very rare, and very fragile. We are living in a span of time in which this planet's temperature does not swing too violently, a span of time in which sea level does not rise and fall by dozens of meters within a single lifetime, a span of time in which the sky is not often darkened by volcanic ash, and the ground is not constantly shaking under forces beyond our control. Across the entire 4.5 billion year history, intervals like this are not many, and they often do not last. That does not mean we are standing at the edge of an ending, but it reminds us of a simple truth. Civilization is not Earth's default state. It is a temporary phenomenon, one that can exist only when this planet allows it. Perhaps the most important thing is not to ask how much longer this quiet interval will remain, but to ask, what have we done inside this rare quiet? Have we learned to understand the system that is holding us up? Or have we grown so used to it that we mistake it for permanence? Earth does not need us to worry about it. It existed long before us, and it will continue after us in other forms, in other conditions. But we are different. We need to understand that stability is not bedrock. It is a flat surface of water, a shape that holds only while the forces beneath it are temporarily balanced. Perhaps in hindsight, people will not call this era the greatest, but it is very possible they will call it one of the quietest eras Earth ever allowed humans to inhabit. And if tonight, as you listen to these words, there is no storm outside your window, the ground beneath you is not trembling, the sky is not falling, then perhaps, if only for this moment, you are living fully inside something extremely rare, a quiet interval that has no name. If you're still awake, tell me where you're listening from and what time it is for you right now. And if sleep has already arrived, let this story close the way Earth itself seems to be doing at this moment, quietly, steadily, and calm enough for you to rest.